The first-year interest group, Science History Detectives, focused on two closely interwoven courses for first semester freshmen, one in art history taught by Ann Smart Martin,
and the other in the history of science taught by Lynn Neihart. The course started with basic ideas of thinking about material objects in art and science, but by its end, the class had mounted exhibitions in the Chazen Museum of Art, Burge Hall, the Biology Building, and Chamberlain Hall, the Physics Building. The overall project was called Capturing Nature, Instruments, Specimens, Art. Students had to learn how to look at an object as a material thing and to think about its various contexts.
Over the next several weeks, our student detectives went on a hunt across campus in search of objects they wanted to put on display. They investigated the back rooms of the Zoology Museum, the Physics Demonstration Collection, and the Chazen Museum of Art. As they did so, they also began to do research on the objects they found most exhibition-worthy. For instance, chasing down the history of the Edison phonograph and Graflex camera in the university archives.
Meanwhile, we were brainstorming about themes for the Chazen exhibition. 6 themes emerged: capturing nature, imagining nature, capturing waves, light, sound, and color, seeking beauty, preserving nature, which is life after death, and we close with a glass gallery that shows the juxtaposition of science and art.
For the two exhibitions in science spaces, the students would have to do their own production. In Burge Hall, students worked in 2 teams to create 2 different niches, while in Chamberlain Hall, another team created an exhibition called The Waves We Perceive Physics.
This is a story of how we got there.
The Imina Ma, or python mask, is a spiritual headdress worn by the Dogon people of Mali. The Science History Detectives include this mask because it helps represent the theme of imagining nature. The imagination of the natural world allows for artistic embellishment and interpretations, as well as alterations and manipulations to change what we see. The Dogon artist created the Imina Ma mask for religious purposes, but it also demonstrates his artistic interpretation of a python. The python's religious implications are shown through artistic needs.
So this is a strange-looking object. It is actually a plankton net of the kind developed by E.A. Burge in the early 20th century. Burge was a professor here at the UW, and he developed these plankton nets to study Lake Mendota and other lakes all over North America, actually. But what's interesting about this is if you take a plankton net out of the lake or out of the Zoology Museum where this normally lives, and you put it behind this plexiglass and frame it up like this, it becomes something else. It becomes almost like an object of art. So, of course, it also has to do with capturing in the literal sense of collecting plankton, but we also thought it was interesting to put together with the art objects. There's background in all of this about the history of science in Wisconsin, and so we thought we would be over here in Burge Hall because E.A. Burge was one of the founders of North American limnology. Our students read about a woman student of Burge's who later became an assistant professor here named Harriet Bell Merrill, known as Hattie Bell Merrill, who went down to South America as a single woman on the search for zooplankton to compare with the ones that Burge had studied here in Lake Mendota. And that's part of what the exhibition about the First Lady of the Lake, Hattie Bell Merrill, it's part of what that is about. The Wisconsin Idea exhibition was that students picked objects from all the collections, zoology, geology, state archives, materials from all over different collections. So that's part of the Science History Detectives aspect. That was the name of the FIG.
So the stand that we're showing you right now originally would have held a very delicate glass model, known as a Blaschka model after its maker, So we've been studying these Blaschke models a lot in our FIG, Science History Detectives, because they really show the intersection of art and science.
The Blaschke models were purchased after a fire in Science Hall destroyed a lot of the university's teaching equipment. They are exceptionally fragile. Today, they aren't allowed to be even touched by anybody or moved.
After the Blaschke models became obsolete as science teaching tools, that's when people really started to appreciate them for their beauty, and that's how they came to be viewed as art objects.
Obviously, this is kind of an iconic idea about capturing nature. A bird cage, a way in which natural objects are confined by humanity. But look at the way the artist Kim Kryler has played on that idea by these birds that are crafted out of enamel and on the cage. So it sort of plays on the idea of capture.
Specifically with capturing nature taxidermically after the objects are dead, and at the same time we have, in the case of the weasel and the rabbit, a taxidermic specimen where the very tiny weasel has captured the much larger rabbit and killed it.
And the thing about the taxidermy was that it's one of those things that people can be kind of creeped out about, right? That it's sort of dead, but not dead, and that there's this real ambiguities of what a taxidermy thing is. We had to keep assuring the students that, well, the reason it's done is for science. It's the study of these objects. So that led to all kinds of questions about what the performance of these things are in different settings. Well, capturing nature is kind of the opposite. It has kind of an opposite form in imagining nature, in that humans actually take nature and do a lot of different things with them. And that's what kind of art does in many ways. Well, here we see a lion, but it doesn't look like a very good lion. And it's on a 17th century piece of earthenware made in Holland, copying Chinese porcelain. So there's this whole global story here from the edging and the framing, which has Chinese elements, but then we got this dorky lion in the middle. Well, think about it. Did this artist know what a lion looked like? Had he ever seen one? Lions were from the other parts of the world, so it's a global story of the idea of the lion and the Asian elements they're trying to copy, and the fact that the lion is the House of Orange, so that's Dutch royalty. What I like about this is that how it pulls all these things about nature into a whole global story.
So this is a very different way of imagining nature here. What we've got here is another object from the Zoology Museum that was called one of the dove unicorns. This isn't a fake Barnum-esque object. It's actually scientific research, and its effort was to transplant the cells that made the horns from two places to one place, and this happened in the early 1930s, and it's the earliest work of stem cell research and cell transplantation. So now we're in the section on waves, and I'm standing next to the Shive wave generator. This was developed by John Shive at Bell Labs in the 1950s, and it became a very famous physics demonstration device. So this one comes from the Ingersoll Physics Museum on the UW campus. It's an interesting object in this exhibition taken out of that museum and put in this one. It raised all kinds of questions about what could be touched, whether you could have something that you could touch in an art museum, and how to deal with putting an object that came from a hands-on physics museum into an art space where the expectation is that people don't touch anything. So one of the things that is all around here in some of the other physics objects are signs that say, please don't touch. And in this case, people are allowed to push the button.
So the thing about the wave idea, and if you can see behind, I mean, we kind of think about when we think of waves in an art museum, and there are other waves here as well, a painting and some glass objects. But it actually exemplifies one of the hardest things we did, how to fit together these ideas. So that mythologizing and capturing, how do waves fit in? Well, part of it is the way that these physics objects are also about capturing.
Behind us, what we have are these old objects from the physics demonstration collection that have been gathering dust in the background for decades that the students pulled together into an exhibition called The Waves We Perceive Physics, with light waves and sound waves and the modeling of waves using slinkies, and also then the curly, kinky waves of the Hittorf tubes and the Geissler tubes, these beautiful glass tubes that are predecessors of neon tube lights. And then there is one object sort of out of place, which was put there kind of as a joke, which is the wavy, curly snake, which comes back to the snakes that we have throughout the exhibition in all 3 locations.
My favorite object is we have a wet specimen from zoology. It's just a glass jar and it's completely full of snakes. Not many people would think of a bunch of dead snakes in a jar as beautiful, but in a way, because of their pattern and their color, they are. And I thought using them in the Chazen and pairing them with other objects that people would immediately see as beautiful, we could make people think more about those issues.
So this is actually one of the more exciting parts of the project. You know, one of our jobs was to go through these various collections and come and look at and try to figure out what they are and if we can use them in the exhibition. Here we found a piece of furniture, but it is a phonograph. And a phonograph with a brass plate that says donated to the UW Physics Department in 1919. By, the famous Thomas Edison. Thank you. So that the whole idea is that now we see an object which has this whole storyline about some very famous people and connections to UW. The other thing that's cool about it is it still plays.
And it's been used in the physics demonstrations to demonstrate the physics of sound and sound waves for many decades.
But that was part of the discovery we were able to make. Go to the archives, find out that Edison actually did give this to the physics department. It's not a fake plate, it's not a made-up phonograph, it is the real deal. So our final kind of thought about science and art in this exhibition, we looked at a particular material, glass. Glass has amazing properties. It can be quite malleable when hot, brittle when cooled. It can contain, it can evoke. And if you think about it, science would not even have been possible in modern terms without glass. And we'll see some of those examples here about why that might be. But it makes things small, it makes things big, as you saw from the lens before you as well.
Glass is, as Anne said, very important to science, but it's not just lenses, although the microscope that we have here, of course, uses glass lenses. But if you look above it, there's also a glass magic lantern slide, which was a standard method for demonstrating scientific objects in classrooms. So we talked about all the themes in this room, but I think it's important to remember that all of these themes were developed by the students in this course who came in at the beginning of the fall of their freshman year as very recent high school students. They didn't know anything about the UW campus other than what they'd learned over the summer during their brief visit here. And they got to explore all of these collections behind the scenes.
So I wanted to just make sure we think about how this show could possibly have come together, in that it was very quick, but it was also could only be done with an incredible set of resources here on campus. We really could think of a collection of collections on this university would be phenomenal, which if we all lined them up and saw them as an entity in themselves. But it was through the curators that helped us extraordinary amount of work. The designers of the show helped us, the people in the Mills Music Library helped us, and the archivists helped us. So there were many, many ways in which all the resources of this campus were brought to bear on this one great experiment. When we started, it was really what can be done. And Lynn and I, it all began too because we would get together and I remember asking, why isn't a microscope in an art museum? It can be beautiful, it can be made of mahogany, it's got lots of good glass, whatever. And that conversation between two different faculty members and two different divisions, I think allowed us to sort of have the freedom to do this. So it's that interdepartmental, intercollegial, and the vast resources of the university that were brought to this that made this a pretty special thing.